Day 2 of ellipses. So first of all, when you think of an ellipse, hopefully you think about planetary movement. Just want to show you a real quick simulation from UNL. This is the orbit of Mercury. If we want to see the eccentricity, the semi-major axis, and so forth, that's all given. So it looks like we only have one focus, right? So if we look at this empty focus, that shows you where the second sun would be if this were a two-sun universe. Does that make sense? So this is the orbit of Mercury. If we show the semi-minor axis, we can see how long that is, the semi-major axis as well. And then I think there's even a start animation, which lets you see this is years per second, 0.2 years per second. And so you can see the elliptical orbit that Mercury happens to follow around our sun. So real quick aside. All right, so the first thing we want to do is see if we can find the standard form of an ellipse if the vertices are plus or minus 6, 0, and the foci are at plus or minus 2, 0. So start by sketching your vertices, and then plot your foci. And then tell me what you know. We can find the center, because if we are 6 over, 0 up, 6 back, 0 up, we know the center has to be 0, 0, the origin. So if this is our vertex 1, our vertex 2, our center is at 0, 0. So that helps us build our equation, right? We need an x minus 0 squared over something plus y minus 0 squared over something else equals a 1. So next we say foci are at 2, 0, and negative 2, 0. What else do we know? We can find A and C. So what is A? 6, because from the center to each of the vertices is 6. So we know A squared is 6. Is this a horizontal or a vertical ellipse? So which of the two will have the A squared beneath it? The X. The X is going to have A squared beneath it. And so we also know, because we know how far away the foci are from the center, what number do we know there? 2 is equal to C. Yep. So our C is 2. And what is our equation that helps us find our other minor? Absolutely. C squared equals A squared minus B squared. So 34 is equal to 36 minus B squared. What's B? Square root of 32. Square root of 32. So if B is the square root of 32, B squared will be 32. And if you want to continue to graph it, to finish it, to complete it, to feel like it's done, we ask ourselves, what is the square root of 32 close to? 5 point something, right? It's bigger than 25, but it's less than 36, so it's not 6. So it's 5 point something. So we could go 5 point something up, 5 point something down, and then we would have our completed ellipse to get our endpoints of our minor vertex, our minor axis. And of course, you've got to do a better job of drawing an ellipse than I do. That certainly doesn't look elliptical. Questions on this one? Okay, next one. So now the second example on your sheet says to find the standard form of an ellipse if the foci are at 0, 0 and 4, 0, and the major axis has a length of 8. So start by sketching your foci. So what do we know? We know the center. Center's the midpoint, right? What's the midpoint of those 2 points? 2, 0. So here's our center. We call this F1 and F2. So since we always write x minus something squared plus y minus something squared equals 1, if our center was 2, 0, then it will be x minus 2 squared y squared, right? We really don't need the parentheses because there was nothing to take away from it. What else do we know? Major axis has a length of 8, right? So we are 1, 2, 3, 4. Did I mess up on this one? 0 over 4. I went the other way. Sorry, I went the other way. 0 over 4 up. Apologies on that. 0, 0, and 4, 0. No, I was right. Okay. I just don't have enough space here. 1, 2, 3, 4. Yes, I do. Okay. I have a space for 4. So the major axis has a length of 8, right? All right, so this was F1, F2, center. So now we know our vertices, don't we? Okay. Horizontal or vertical? Horizontal. So which one gets our a squared under the x? And we know that a is, the whole length is 8. So a is 4, and a squared is, so 16 goes beneath the x minus 2 quantity squared. So now we need to find b. And we have c. C is how much? C is 2. So since c is 2, we need 4 equals 16 minus b squared. So if we subtract 16 from both sides, if a negative 12 equals negative b squared, b has to be square root of 12, which is 2 square roots of 3. Okay? So our 12 goes beneath the y squared. And if you want to complete it and be able to sketch your graph, the square root of 12 is something close to in between 3 and 4. So we're going to go 3 up roughly, 3, a little bit over 3 up, and a little bit over 3 down. And then we'd sketch our ellipse. What questions do you have on this one? All right, feeling good. Next one. Standard form of an ellipse. If the center is at 3, 2, A equals 2C, and the foci are 3, 5, and 3, negative 1. So we've sketched the points that we have. What do we know? We have C because C is 3. We moved 3 up, 3 down from the center. So do we know what A is? 6. Horizontal or vertical? So which one is squared? So we know AY minus 2 squared has to be over the 36. And the x minus 3 squared has to be over something else. How do we find B? So 3 squared equals A squared minus B squared. So 9 is 36 minus B squared. What will B squared be? 27. Okay, so B squared is 27. And so if we wanted to, that's about a little over 5, right? So we would go a little bit more than 5 to the right and to the left. From our center. And we're going a little bit, we're going 6 up and down. And then we sketch our ellipse. You see how these are easier than the ones we did yesterday? Not convinced? Not nearly as much completing the square. Or no completing the square today. All right, last example. Standard form of an ellipse. If the vertices are 0 plus or minus 8, and the eccentricity, E equals 1/2. So start by sketching your vertices. God bless you. What do we know? We know A is 8. And we know the center is the origin, 0, 0. We have E, so we can find C, because E equals C over A, and 1/2 is the E. C we don't know, but 8 is our A. So if we cross multiply, 8 equals 2C, so C is 4. So far so good? Okay, that means our foci are going to be 4 up and 4 down. Not that we need them, but just to make sure that we remember. Horizontal or vertical? Vertical. So our A squared is beneath which one? The Y. A squared is 64. So all we need to do is find B squared. So c squared is b squared minus a squared, right? Sorry, a squared minus b squared. Decided to change it up for whatever reason. Incorrectly, of course. A is, thank you, 64 is the a squared, and 16 is the c squared. So if we take away 64 from both sides, negative b squared is negative 48. So b squared will be a positive 48. And we don't really need the square root, right? It's a little bit under 7. But we need the b squared, so we'll just write our 48 here. And if you wanted to complete that sketch, we're going to go just a little bit under 7 out and a little bit under 7 left. And then we would have our endpoints of our minor axis so we could sketch our graph. Questions? All right, so put yesterday's assignments and today's together. Same page, same graph paper. You're welcome to grab graph paper if you want. Yes, I've assigned only odds. That means we don't, or for the most part, odds. Don't just copy them out of the back of the book. Work them. Use that as a check. Evaluate yourself. Make sure you know what you're doing. Tomorrow we talk about hyperbolas, and then we put it all together.